everyone. Hi, good evening. My name is Luba, and today we're going to talk with you about building a high-performance POI server using Go. This event is hosted by Intellias. It's a global technology company with 14 delivery centers across the globe, international clients, and also a lot of open positions. So I will share the link with you to the chat, and feel free to check out some job opportunities. And I want to introduce our speaker, Viacheslav Shkurychev. Yeah, he will be with you today, sharing his experience. Feel free to write your questions in the chat, and at the end of the webinar, we will have a Q&A session. Hello, Viacheslav. Nice to see you, and good luck with your speech.
Yeah, hi everyone. As understood, if we're all here today, you're pretty interested in technologies related to Golang and to some different stuff, maybe about the automotive area or something like that. So let me introduce my idea and what we're talking about today. Today we are talking about building POI server. What is the POI? POI is the point of interest. Something like, I don't know, when you're just driving your car, you can take a look on your map and find something about a cafe or train stations or anything basically marked on your map that can be interesting for you. So in automotive area, you can face with some tasks related to collecting, facilitating, and searching through a lot of information related to POIs. For example, you can have your custom built map and you can show people who's driving the car different stuff, or just advertise them, or just show it on demand, for example, in offline or online mode. Never mind. So what we are doing today? Today, our agenda is to describe what we're going to do overall. First of all, it will be presentation and workshop. More workshop with code and showcases around everything related to our topic today. So next, we will talk about overall the very useful stuff as OSM database, OpenStreetMap. Maybe you're just familiar with that, but it will be interesting. Then we will talk about how to store, how to search, how to filter coordinates from the map, and how to work with them in the storage. Then I will show you how we'll import our test set of POIs around the globe, right? And then we will talk about the HTTP version 3 as the base to build our API, because it's main topic today, how to build something that will handle a lot of requests per second or simultaneous users per second. Then I will show you the code, how API was built, what the hacks, what the differences, how basically to do everything what I will describe today. Then I will show some simple user interface, not just to be just boring API, but have something to click and to move on the map. And in the last stage, I will show you how to test, basically how to tap everything that we built today. So let's go. First of all, let's describe our goal. Our goal is to build a server that will provide POIs, maybe as an array. So it means that we will query our API with some search field, some search parameter, or with some distance around our current location or any location. And we need to get the POIs according to these criteria. So what the crucial? We need to support search. So I will be able to search by names of POIs. I will support the filtering, because we will have a lot of different types of POIs, for example, restaurants, hotels, or something like that. And the most interesting, we will support the search by distance around some random point. So the requirement, we need to pass some point and to get the results around this point. So it's our goal for today. Let's start. Because we need to work with something today, we need some test set of data. And we will take a look at very cool servers and set of the data called OpenStreetMap. What is that basically? Let me share another window that I will show you for anyone who is not familiar with that service. It's basically looks like that. It's like regular Google Map or anything like that, but with some distinction that it's totally free and open source. What does it mean? It means that all of this information is gathered by community, by different people around the globe, compiled and maintained by open source community. So as you can see, you can navigate by map and open anything, just like in Google Maps. How it's working? It's working in two different modes. First of all, I will share the presentation again. Right. It works in two different modes for us. First of this, sorry, maybe you can see anything. Yeah, but I will share again. Right. First of all, OpenStreetMap provides us with style service. It means that you can build your application requiring the map and load the tiles. It's the squares from the map by this service. You can just set up your library, your favorite library, for example, for mobile application, and it will use the tiles, render it from the OpenStreetMap. And second thing that is very important for us today is geodatabase. What does it mean? It means that we have database with all of the streets, all of the buildings, all of the points of interest around the globe. So it means that they have some dump in the internet, and by downloading this dump and parsing this dump, you can have access to all of this information, and you can freely use this without limitations, almost without limitations. So how it looks like? Imagine that you have the four different instances, types of the data. Basically, it's a relation, it's the point, and some area, for example. And you can describe it by coordinates and attach some fields to that and pack in, for example, XML format. And then you can just compress it and provide with some additional notes how to use it. But imagine how large this file will be. It will be around, I don't know, about 1 terabyte and more and more and more. So OpenStreetMap supports special format that's based basically on protobuf. So we're just storing the data in binary format, pretty efficient way. Sorry, and we can use this dump freely, but using the special libraries. So, what the benefits of this format? For example, if we if I will store all of this information, POIs, I mean, and everything from the globe in XML and compress it using the gzip, this file in protobuffer binary format will be half of the size of this previous file. It's pretty cool. For us, the second thing is more important, that we can compress, that we can read from this file 6 times faster than gzip planet file. The next thing is that if we're trying, for example, to write our own file, for example, we can download the world file, parse this, filter out some unnecessary things, and pack in this format again. It will be 5 times faster to write this file in comparison with gzip planet file. And the most important thing, one of the most important thing, that it's smaller, even in comparison with busy planning. So how to work with that? Because if we're talking about some libraries, we can, for example, read the XML and parse it using Golang easily, or JSON or something like that. But PBF format requires some manipulations with protobuf. Fortunately, a lot of different libraries and tools exist, and one of these tools called one of these libraries called OSM. You can see at the bottom of my screen the link to that. And if you're working with Golang, you can just import this tool and use as you like. You can just work with the file and read all of these entities, and it supports multiple coroutines. So don't worry, you will utilize all of the CPU powers of your computer. So the next thing, let's talk about how to store coordinates. For example, if we have such file, right? For example, we downloaded all of the information from entire planet, and you need to decide how to store GPS coordinates, because our goal is to download this stuff and facilitate the request to that, not just hey guys, let's parse and return some information, but we need to find across this information. Basically, a lot of databases, especially geo databases, exist nowadays. So I can just select today 3 of them and talk a bit each of them. So Postgres database. What is that? Basically, is maybe you know that Postgres don't have any built-in support for any kind of manipulation with the coordinates. So you can download and install the set of extensions that's called Postgres, and then a lot of features will be available for you. If we're talking about working with Postgres, working with different coordinates related to different geometrics, and even, I don't know, work with different paths, or not just complex structures. I mean that you can describe a custom complex form and just to look up the points inside this form, right? And what the advances of this approach? That it's very comprehensive. It supports a lot of stuff related to processing the data in comparison with another databases, because Postgres is the complex software just designed and developed just for this purpose. You can find almost anything related to working with Geo. So it's very fast. It's pretty not bad optimized for complex queries and large data sets. For example, if you will try to parse protobuf file from the planet using some tools, not just library in your application. You can use built-in, not built-in, but recommended tools by OSM, and it will utilize Postgres as the main database to parse this file and fill all of this information in some database. It will be Postgres. So it has a very strong community, and it's very frequently updated. So you can't be worried about outdated version Postgres in relation to the current version of Postgres. So the next thing is MongoDB. I like MongoDB as a technology because it has a lot of modern features built in natively. And one of this feature is support of geospatial data. So it's pretty easy to insert your coordinates as a JSON and create just index, and pretty easy to use this. And I can say that performance of such queries not so bad. I like it. So the next thing that we can use, that's Elasticsearch with Geo features. Personally, I like Elasticsearch, but the problem that can occur that even with a small data set, you will require a lot of resources, for example, RAM. So you need to remember, first of all, that it uses the Java, and whereas the Java, it's a lot of requirements to your hardware. But this difference will be wiped out if you have a very, very, very large data set. So as you can see, we have some of the options, and today I will choose MongoDB because, as I said, it's very easy to use. For our demonstration, it's very good, right? So let's proceed with MongoDB. So one of the last thing before we can start our development process is the decision how we can facilitate, how we can process our requests, because nowadays we can have a lot of options how to do that. For example, you can use REST, or you can use gRPC, connector PC, maybe you can use something like that. So today I want to describe and touch this topic about HTTP version 3. Because HTTP version 3 appeared as a draft of specifications years and years and years ago, but our area, just adopted this technology not so fast as I wanted. So a lot of people just kept in mind about HTTP version 3, but were just afraid to adopt it on real projects. Today's situation is very good because the most of the latest web browsers supports HTTP version 3. A lot of clients, libraries, and servers supports it too. And let's talk about why HTTP 3, not 2, not anything like that. First of all, it's UDP instead of TCP. It means that now the request in your browser can be look like just a web call. It means we are streaming the tons of data using just UDP. And we have some protocol, some specification, how to facilitate, for example, data drops, because it's a problem that's solved by TCP previously, that TCP have some session and have retries, so it sends your packets, dropped packets again, just to be consistent. So today we have fixed this problem in QIC. So you're not to be worried about it anymore. And for example, if you tried lately, you tried to maybe you was interested how we can facilitate the parallel request. For example, if we are navigating some web page, we are opening some web page and a lot of images exist on this page, JavaScript file, how it possible to download it in parallel way. We had two not so good approaches. First approach to open multiple TCP connection from our browser. That's bad because we are holding resources of our service. The second approach, to use one TCP connection, but simulate something like parallel request. And problem exists, for example, if we have one packet dropped, so we have head of line blocking. It means that everything hold until we recover our packet, until we just retry this, and then we can proceed with it. So as I said previously, in UDP, we can act just like some stream. So we can send finally data truly simultaneously and not block anything if we dropped some packet. So we will handle it in parallel way. It will not block, for example, downloading your JavaScript file in browser. So it's the first benefit, the most important from my side. Second one thing is built-in security, because you can't use HTTP version 3 without encryption. Encryption built in a native way. It's very cool feature. So fewer handshake you need to perform and less data exposed during connection setup. So for example, it's just cool because I think nobody will use unencrypted server today. Then we have improved performance over challenging network. As I said before, we have support of recovering packets, right? And HTTP version 3 does this much better than previous version. And then reduced latency. For example, as you know, if you're just establishing TCP connection to use it for HTTP request, you're doing that, then you're sending the headers, then you're getting the response. Now you can just open connection and already communicate with server without a lot of handshakes, without additional need to do that. And all of this stuff will be in parallel way, as I said. So then, sorry, then let's begin our journey from this stuff that I described. Let's create some tool that will utilize the OpenStreetMap to import this data in our database, because we don't have anything that we can test and that we can use with our future API. So let me share my screen and open IDE. Right. So I prepared code and everything for you today, because I don't want you to get bored and take a look at how I'm typing anything. I already created all of this code, and I want to focus and involve you in some journey about how it looks like. So we have import tool, and as I said before, maybe I will increase the font, right, to be just to be more visible. Right. So let's start from the import tool. What we will do, we have, as I said before, the special library that uses the that can help you to parse and read data from dump of this OSM world file. And then what I will do today. So I will start from connecting to database. I will use the MongoDB library, and I just wrote the repository where I'm creating the connection to database. And first of all, I'm creating indexes because, as I said before, to use our data efficiently, we need indexes. And we have different indexes in MongoDB, and one of these I will use 2D sphere. What does it mean? It means that MongoDB will take a look at the coordinates, build index, and will efficiently utilize this to perform some search to return some subset of these locations around some point, just like we need to do. So the next thing, I will use the text index because to perform some search across the names of these points, we need full text search. And I like this database again because, for example, in Postgres, it's quite complex stuff, and it's not so good without installing the additional extensions. So in Mongo, we have a native way how to perform text search. And I will create the index for type because our structure of locations will have these three fields: location, name, and type of location, type of POI. So let's take a look how it will look like in database. I created the model POI. I created location that includes type that will be constantly point because type it's a requirement from MongoDB. I have type and I have name, just like I said before. So let's go back to our main function. First of all, I'm creating the collection name. I'm creating the indexes. To do that without additional logging, I will panic if something occurs because it has no sense to continue if we fail these steps. And then I will create the different mechanism to utilize the coroutines. So I will add the option. I will have the function that inserts POI. How we will insert this? It's pretty easy. By calling one line, D collection insert one. And I will insert the POI. So I'm going to do that in an efficient way. So I'm going to do that in Go routine by reading the channel because our file it's not consistent file, but this file can include different routes, different areas, and POIs, and it can be mixed. For example, I don't want to just wait for next POI and just not to utilize our powers to insert the POI. So I will use buffered channel. So we can write a lot of 5,000 basically POIs in this channel and in parallel way insert these POIs while we're searching through the file to find additional POI to insert. Then I decided this file pretty big. It can be up 100 gigabytes. So if I will do this once, it has no sense to work with this file locally. I don't want to download this file. So I decided to use streaming and to write, to use the reader just to open this file on the, perform the GET request to this file on the internet, on the service. And instead of downloading this, I will define overall length of this file. And then I will perform the read operation. So I wrote some structure called method reader. It's not structure. Sorry, it's a package, and here we have the right structure. Here I have read closer, and I included fancy progress bar. So by progress bar, I can take a look how much time I need to finish this process. And here I have read closer. And if we will take a look the next, I will use this library to create the scanner. And this scanner will utilize this mReader. So I will get my data to scan using this library, not from my local file, but just from the internet. I will download this file, and scanner will use this data right from the stream, from the internet. Okay, so let's start to do that. Here we can fill the information, how many processes we can use. I recommend, if you will use OSM library in the future, I recommend to choose the number equals to your course and processor. So then we will defer to close our scanner, and then I will call scan. It means that I am waiting for some object, and while I have the object, I can perform scanning. Here it returns the object, and from all of this stuff, I need just node, because points of interest is basically node. We can have a lot of nodes, something like as I said, railway stations, restaurants, and other. So I'm getting is as a node. If it's not node, it will return false in OK. If we don't have any text because we need to extract the information about name, we just continue with the process. We're not taking a look at this. So then, for example, we found the POI candidate. We're filling this with point. We're filling this with coordinates from information from these fields of the node. And then we're trying to find the name. If we found the name, we're assigning the name, because this format includes different tags, and we need the tag the name. In this tag, we have the information about name. And then I created the function to filter out any unnecessary information about POIs, to just insert only the POIs that we need. I will show you. For example, I just chose the POIs of types that I am interested in. Restaurants, coffee bars, and another stuff. So if we have the POI of this type, we will include this. So if we have the name field in, if we have type, we're just sending it to the channel. And as I said before, we have the channel. We're reading from this channel and inserting the POIs. So this code overall, as you can see, around 100 lines of code. It's pretty small for such stuff. And by using this thing, I successfully imported POIs from the world file without any downloading. So, right. Let's continue. After using this tool, we have the database as a result. And then we can start to implement our API. As I said, we are using the API with HTTP version 3. So HTTP version 3 is not included natively in Golang. So you need to use the library basically for that. You can choose this library, the most widespread for that, HTTP version 3 from QUIC Go, and it just works like any other HTTP server. For example, I described for me two endpoints. First of this is the search, just to perform search by radius, by current point, and by name. So I can search through that. And second one, I just preserved for my front end. I will show it later after this section, how it looks like and how it will be served. So how HTTP 3 server works, we have the package HTTP 3, and we are calling listen and serve TLS, right? And we need to pass cert file, key file, and UMX. So you can utilize your favorite one. I just used the regular one from the package HTTP. As you can see, it's pretty flexible, so you're not locked on something custom. The difference for you is the signature, how you're starting the server. If you will take a look at HTTP 3 package, you will find different names. Is the listen and serve TLS and listen and serve QUIC. What the difference? The difference is the, for example, if your client is not supporting the HTTP version 3, then you will serve the regular request and you will include some header that just signals that this server supports HTTP version 3, if we can work with it. So you will have the back compatibility, you will not crash your current clients. So it will be transparent way to implement this for you. And then after that, it's pretty interesting thing. Let's talk about how we are doing the request in HTTP 3, because, for example, as you understood, it's not TCP but UDP, but browser, when you're just typing the domain and trying to fetch the page, it tries to establish connection by port 80 by default. So you just need to use that to signal the browser that you need to utilize UDP. Fortunately, we have some ability to add in the domain such information that this web page utilizes the HTTP UDP protocol. So don't worry, it will be working without any problem. So let's take a step back. How search POI works. Here we have our handler, and just to omit some complexity related to validating the queries, we just trying to parse float for latitude, longitude to define the point around what point we will search for POIs. We will parse distance in meters, and we will get the type of POI and name to search by this name. So then I will call the find POIs, right, in the repository, and then just respond with this information in JSON format. And just to use the streaming, I am creating the encoder and just encode the POIs right to the client. So let's take a look how we'll be working with MongoDB in this case. Basically, it's pretty easy. So as you see, we already have latitude, longitude, distance, POI type, and search term. And here we're using filter. We're creating this one. In this filter, we can use geo within. And this geo within allows us to use it alongside with text search without any problem. Maybe you just had the experience and tried to use the near, but unfortunately, we need to use geo within, right? And if POI type is not empty, we appending to this filter also type. So we created previously the index for that to filter by type with normal speed, and then search term. Here we will use the text query, and we will search by search term that optionally can be passed here. So then I will use projection to filter out all of these fields because we don't need, we will protect our output from different stuff. And we're just sending the query to MongoDB with find command. And after that, we have our POIs. We are just decoding this in the models and returning. So in this handler, we just successfully responded with the results. So how it looks like. Then let's take a step into the UI because I want to show you also how it's working with real map by using the OpenStreetMap in the browser. And let's take a look at the front end. If we will go to the front end, we will see pretty simple code. It's just for presentation. It's not production grade, but I decided to use just embedded file system to that. I'm just getting the index.html from static directory and just responding with HTML. So let's take a look how it works. We have static. We have index.html, and maybe you know, maybe not. There is a very popular framework to use some custom app called Flat. So I'm including the resources related to that. I'm including the JavaScript, and here I created the dictionary with the icon map. I created mapping for the icons because I want it to be with some pictures. And after that, I'm setting the view of the map on the current location. I'm setting the tiles, the URL with tiling server from OpenStreetMap. As I said at the start of the presentation, the OpenStreetMap also provides us with tiles. Tiles is the squares of map, and we can use it in our, for example, leaflet library. So after that, we have the function create icon, just to have icon on our markers. And then we have function fetch and display markers. Basically, we're utilizing our API that we wrote before, sending latitude, longitude, and radius without any additional text search. And then after that, we're just parsing this information and plotting the elements on the map. So basically, that's it. So let's go to demonstration, how it's working. Let me share another screen. Right.
Yeah, sorry, we just got some technical issues. Our speaker will be back in a minute. Yeah, Viacheslav, you're live
Okay.
again. So
Yeah. I'm glad. So, can you see my screen?
yes, it's okay.
Right. So, let's continue. So, let's navigate to our service. Right. Yeah. So I just loaded, I deployed temporarily this code to the web server. So you can navigate to that. So I can navigate basically because I will shut down the server lately. So you can navigate to the map and see the POIs just on the map. For example, in Germany, cluster it by them. So we can see that we're loading a lot of POIs pretty fast because in the database we have the around 5.5 millions of different POIs around the globe. So as you can see, we're loading this with pretty not bad speed, right? And as I described before, if we will take a look at our POI, we're plotting the different icons. Okay, it's not so interesting because here we for backend part, but still you can see it's pretty awesome speed. And let's take a look at the full features of this API because as I said, in UI, we're not utilizing all of the fields, just the radius. So I will share my Postman. Right? And here I'm utilizing the point and distance, for example, 100 kilometers. And here I want to fetch railway station, and that has in the name the alt, for example. And I can send this response. You can see that for around 100 milliseconds, you're fetching the results. So it looks like it's working. Not bad. For example, we can expand the radius for 1 million meters, and as you can see, the response time is not getting bigger and bigger, but data, we have more data than in the previous step. So what we can do with that, we can test this for load. Awesome. So let's open the MongoDB Compass. And I will share again with you, but MongoDB. So I connected to deployment. Here you can see in points of interest the 5.5 million, as I said. Here we have the storage size. It's 300 megabytes. And the index just the same as the storage size. Why? Because we created the indexes. We created the indexes for our location, for name, and for type. And I can just open performance matrix and see that now we don't have any load. It operates well. And let's just tickle our service to perform some tests. I created the stress test, how it works. I'm just filling the number of clients. I am creating the clients in the loop, and I'm performing random search requests in the loop. So first seconds, I will have some warm-up, not just to make a lot of requests simultaneously, but just simulate the real conditions. I have API and I have URL, sorry, and I'm performing this test constantly in the loop. And about the results of response time, I'm sending this to the channel, and in the channel, I'm getting the information about how many milliseconds it takes. And to make it more robust, I'm using the random location just to prevent the over caching my request, to prevent the caching the one single request for everything. So let's go back to our compass. And sorry, let's go back to our code, and I will show you how the code looks like to test and stuff. Okay. Right. So here I am calling perform random search request. I have URL. I'm generating the random coordinates, and I'm doing this in the loop, as I said before. So let's start our application with stress test and wait some time because the first connection can be dropped, for example, and then we will have the results because a lot of stuff just trying to connect. So we have increasing response time, and in this time we can switch back to our compass and take a look how our requests are going to our database. So you can have the explanation from MongoDB Compass that we have around 5,000 operations per second. We have the hottest collection and everything is good, right? It's pretty smooth. And if I will take a look at my testing window, I will stop the stress test and I will show how it was. I hope I'm back, right?
Yes, it's okay.
Right. So, okay, if I will take a look at my screen now, after some time, we have constant response time. So average response time is not increasing dramatically. So we have around 5,000 milliseconds per request. So as you can see, it holds the traffic, and we can serve this to at least 2,000 people on one instance on one small server on VPS provider. So, for example, if we have increasing traffic, we can use the replication set and decrease the overall load to our server. And for example, if we will use the HTTP version 1 or 2, it will be dramatically worse, because for every request, for example, if we can use keep alive connection, it will be okay. But TCP connection much heavier than UDP traffic that just streams to our server. So thanks a lot. I hope that it was interesting for you. And now we will move to our questions, I think, right?
Yes, thank you so much once again, Vyacheslav. You can open the chat. I sent you so many questions. I guess you answered on the way a few of them. So the order you like.
Okay,
Just
right.
pick.
Let me take a look. So, okay. Can you send the history, because after reconnection, I lost
Okay.
everything.
Yeah, once again, I will do it. We start with this one. I will just send it once again to the chat one by one as we got them.
Yeah. Okay, first of all, instead of Elasticsearch, is it possible to use OpenSearch, which is open source compared to Elasticsearch? Right, you totally, I agree with you. You can use anything because, for example, nowadays we have a lot of databases, and you can choose anything that fits to your requirements. Right, you're totally right. But you need to investigate what you need to have and how much resources you have for your task. Because if you will create the cluster or just empty instance, and we will have some, I don't know, thousands of points, it has no sense to spin up something heavier. So, what the biggest performance bottleneck you foresee when handling planetary scale SM data? The most bottleneck, one of the biggest, I just tried to profile my code because it was pretty fruitful to see where is bottleneck and what takes a lot of CPU power. A lot of stuff related to encoding, decoding information to parse the response from database and another stuff. So maybe if you're interested in just making your server even more lightweight or something like that, you can maybe test the approach with gRPC because gRPC uses protobuf. But unfortunately, the way if you're using the HTTP client, it will be this layer. So the most bottleneck, if we have very fast database, still is this communication layer for my test between database and Go application. Right. How do you manage updates or change in OSM data for real-time application? Are there any emerging technologies or trends in geospatial data and protocols that we should keep an eye on? Basically, if we have updates in OSM data, for example, I don't know basically, do we have any special software just to handle updates because OSM data really changes pretty frequently. I think that you can create the, for example, versioning. You can create unique indexes, and you can create. I'd create the task to run this import tool, modify this import tool, and run it from time to time. And for example, if we have latest version of our OSM point, I will replace that. Just check if it on this right coordinates. I will just replace it. I don't know, maybe something like that. I'm not ready to say about production grade solution for that. QUIC, the next question. QUIC is the reason for high data throughput in order to send much data across network. Could you share the stress test also? How many users you simulate to stress? Okay, maybe it was the question before I showed the stress test. What do you think? Is it possible?
Yes, it was actually on the way
Yeah,
before you
yeah.
did that. So
Yeah, right. So if we're talking about high data traffic, basically the worst problem to handle the sessions on our server because traffic is a different layer, but our bottleneck on every time is ability of server to handle TCP sessions, to reach out limits of TCP ports, and for example, if client have unstable connection, we can use we're forced to maintain the repeatability of the packets. And if we're talking about the TCP, we can spend much more time to handle this and hold our resources more time for one user with unstable connection. So maybe anyway, we need to just to choose something one that we need to solve. On my example, I'm solving the problem related to basically TCP and parallel queries. Something. Okay, the next question. Instead of protobufs and encode and decode the payload, we can use flat buffers instead that reduce this task. However, using ppprof would validate the idea. Right, so profiler, it's very good way. As I said before, I just debugged my code with that. And as I understood this question related to gRPC question, because Now in our presentation, we're just encoding, decoding with JSON. Right. Right. You're totally right that we can choose a lot of things instead of JSON. Personally, if we're talking about me, I don't like JSON so much because I'm from automotive area and we have some our clients prepared by us and we can choose anything, while JSON is actually we need to use when we are working with browsers, for example, because we don't have a lot of choice in comparison, for example, with mobile application where we're writing this and we can choose any protocol or format of exchanging data, right? So, do we have any questions anymore?
I think we are done. Thank you then once again for such an insightful webinar we had, a workshop, and I see the one about where can I send my CV. I will send the link to our career webpage, and you can check. We do have some open positions for Golang engineers now. So if it's interesting for you, get in touch with our recruiter or just submit your CV on the website.
Yeah, from my opinion, I'm working in Intellias with automotive, and it's I'm very satisfied with that because we solve a lot of very interesting tasks. We have the flexibility, and we can affect the decisions how we're choosing the technologies. And I see that people that advise. To choose different approaches in Intellis, you can propose, and if this approach is better than proposed, you can go with this way. You have a lot of opportunities to do that. I recommend this stuff. If we're talking about job in automotive area, I'm pretty satisfied.
Glad to hear that. Thank you for your feedback. Okay, so thanks once again for this great session. I'll just ask once again if anyone has any questions, but I think we are done. Viacheslav, you did a great job. Our viewers, thank you for being so active and having this